Assalamualaikum to one and all. Welcome back to my video tutorial in high school chemistry. In today's episode, we focus on molarity of a solution. How do we calculate the number of moles of solute in a liter of solution? You will find out the answer in just a while, so just stick around, watch and learn. Question number 1. What is the molarity of a solution made by dissolving 2.234 grams of magnesium chloride in enough water so that the final volume of the solution is 250.0 milliliters? And question number 2. How many grams of potassium chloride must be dissolved in water to make 500 milliliters of 0.5 molars solution? When we say molarity, we mean the number of moles of solute in 1 liter of the solution. For example, when you put 1 mole of sodium chloride, that is about 58.4 grams, in a big calibrated container, then you carefully add enough water until the volume of the mixture or solution is exactly 1 liter. Then you now have a 1 molar sodium chloride solution. The formula for molarity is capital M equals mole solute divided by 1 liter solution. In question number 1, we are asked to find the molarity of the 0.250 liter solution containing 2.234 grams of magnesium chloride. And finding the molarity requires us to determine first the number of moles of the solute. There's just one atom of magnesium with atomic mass of 24.3 atomic mass unit and 2 chlorine atoms, so that's 2 times its atomic mass of 35.5 atomic mass unit for a total formula mass of 95.3 atomic mass unit, or when expressed in grams per mole, we get the molar mass equal to 95.3 grams per mole. So this is the molar mass of the solute magnesium chloride. The number of moles of the solute is just equal to the mass in grams of the solute magnesium chloride, or that is 2.234 grams divided by the molar mass of magnesium chloride, or 95.3 grams per mole. So doing our math, we get the mole solute equal to 0.0234 mole. And then, using the formula for molarity, capital M equals mole solute divided by 1 liter of solution, we get the molarity, capital M, okay, equals 0.0234 moles divided by 0.250 liters. Again, doing our math, we will get the molarity, capital M, equal to 0.0936 molars. Moving on to question number 2, you're given the molarity of the potassium chloride or KCl solution, which is equal to 0.50 molars. All right? This is in a given volume of the solution equal to half a liter or 0.500 liters. The molar mass of the solute is equal to 74.6 grams per mole. And this molar mass is obtained by just adding the atomic masses of potassium, which is 39.1 atomic mass unit, and that of chlorine, which is 35.5 atomic mass unit. Right? So, the formula mass of potassium chloride is 74.6 atomic mass unit, which when converted or expressed in grams per mole, then that would be the molar mass of the solute potassium chloride. And our target variable is to determine the mass in grams of the solute potassium chloride, which we denote here as X. And that is to be calculated using the formula. Mass of the solute X is equal to the molarity, right? Capital M multiplied by the volume of the solution, capital V, and multiplied also by the molar mass of the solute. So substituting, we get 0.50 moles per liter. That is the molarity expressed in moles per liter, times the given volume of the solution, 0.500 liters, and then multiplied by the molar mass of the solute or potassium chloride, 74.6 grams per mole. So doing our math, we will get the value of X in two significant figures, which is 19 grams. And this is the mass of the solute potassium chloride, which is our final answer to question number 2. And that ends our tutorial for this topic. Till the next episode, mabuhay, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.